Here we're looking at solving one-step linear equations. We'll look at two principles. This first one, the addition principle. We looked at these in class. Just some more examples to maybe more formalize it. Part A. Solve x plus 4 equals 10. So the question that we ask, and we talked about this in class, is how is that 4 connected to the x? It's connected to the x through addition, and so we do its opposite. The opposite of addition? Good, subtraction. So we are going to subtract that 4 from both sides. As we talked about in class, whatever we do to one side, we have to do to the other side to keep this equation balanced. So we have 4's cancel out, and we'll get x equals 10 minus 4 is 6. Now what should we almost always do with these equations? Is to check them. So let's plop that 6 back into the x and see if it checks out. So we're going to have 6 plus 4, is that equal to 10? Of course. That was an easy one. So we're very confident our answer is right. Now part B. Again, pause the video here. If you've gone through class, you probably already know how to do these. Let's see what you got. Alright, welcome back. How's that 6 connected to the x? Through subtraction. The opposite of subtraction is addition. So x minus 6, we're going to say plus 6 to both sides. And I'm going to get x equals 6 minus 3 is 3. And the checking is 3 minus 6 equal to a negative 3. Yes, it is. How about this next one, part C? 4 plus a equals negative 9. This 4 is an understood plus, right? So I'm going to subtract 4 from both sides. And I'm going to get a equals negative 9 minus 4 is a negative 13. Again, we can check this. 4 plus negative 13, is that equal to a negative 9? And it sure is. We have 1/2 plus x equals 2/3. Again, how's the 1/2 x the 1/2 connected to the x? Through understood plus here. So I'm going to subtract 1/2. We don't change our method because of the fractions, although there is another way to do the fractions to maybe make it a little bit easier. And we'll talk about that in the next lesson. We're going to have x equals 2/3 minus 1/2. If you recall, to combine fractions when adding or subtracting, we have to get a common denominator. In this case, it's going to be a 6. So how do we make this second term? How do we make that 3 a 6? We multiply it by 2. So multiply the bottom by 2, so we have to multiply the top by 2. Similar for the next term. How to make that 1/2, that 2, how to make that a 6? I multiply by 3, and so I have to multiply the top by 3. So I can multiply any number by 1, doesn't change its value. This is what allows me to do this. Okay, so now we do the 2 times 2 is 4. 3, I did that right there, then 3 times the 1, and then we still carry the minus there, so we have minus 3. And so 4 minus 3 is 1, so this is going to be 1/6. Okay, so now let's look at a few quick problems on the multiplication principle. So again, we ask ourselves the same question. Solve 5x equals 20. How is that 5 connected to the x? It's connected to the x through multiplication, so we do the opposite. We divide. Now another way to think of this is multiplying by the reciprocal, right? So there are two ways to do this, and we'll do them both ways. So I can divide by 5. The 5's cancel out, and I'll get x equals 4, and we can just, how about mentally check this out? 5 times 4 is 20. That checks out. Another way to do this, just to show you another way to think of these, is I can multiply by the reciprocal. So the reciprocal of 5 is 1/5. So I can multiply both sides by 1/5. So these 5's cancel, and I'll get x equals 5 goes into 20 4 times, and I'll get x equals 4. Exactly the same thing. Why would you want to do it this way? Well, later on you may end up with a fraction here, like 2/3. And in fact, we'll see one here in a little bit, I think. And it's sometimes just easier to think about it that way. Either way is fine, though. When it's not a fraction here, I generally do this first way, just dividing by that. Pause the video here, see if you can do these next three on your own. All right, welcome back. So 3x equals 13. How is that 3 connected to the x? Good. Do multiplication. The opposite of multiplication is division. So we'll divide both sides by 3. And I'll get x equals to 13/3. And that's a perfectly acceptable answer. We can leave it like that. If this were wrapped up into an application problem where we were talking about money and this equation plopped out, we would want to convert that to decimals, etc. Part C. How's this -2 connected to the x? Through multiplication and with division. Let's cancel. So x equals -10 divided by -2 is a +5. And this last one, again, I'm going to divide through by -6. So x equals, and I usually bring this negative up, just looks a little better up here, -9/6. And I can reduce that fraction, right? So 3 goes into 9 3 times, and 3 goes into 6 2 times. So -3/2 or 1.5. Okay, a couple more. We have x over 4 equals -8. So how is that 4 connected to the x? We have x divided by 4. So how do I remove the 4? Multiply. Good. I'll use the dot to emphasize I'm multiplying here. 4's cancel on the left-hand side, and I'm left with just an x. How about on the right-hand side? We have -8 times a +4 is a -32. And we can check this out, right? Plug that -32 back in for x. -32 over 4, is that equal to a -8? Yes, it is. Okay, part B. Now here's where that method of multiplying by the reciprocal comes in a little handy. I wanted to show it to you without the fraction first, just to show you that it applies for anything that's there. We have 2/5 x equals -10. I could divide through by 2/5, but that creates an extra step. It looks a little messy, so it's easier visually and fewer mistakes if we multiply by the reciprocal. So multiply by 5/2. Because what happens if I multiply by the reciprocal? These 5's cancel, these cancel. So I'm left with just a nice x over there. And then I have -10 times 5/2. 2 goes into 10. 5 times -5 times +5 is a -25.